Hello friends and welcome. Our today's experiment is to verify truth table of full adder using TinkerCAD. So in the last video we have seen the simulation of half adder. Today we will see the simulation of full adder using TinkerCAD. So as you know friends, this is basically the circuit diagram for full adder, which consists of XOR gate, AND gate and OR gate. So basically here we will need two XOR gate because XOR gate has only two inputs. So in order to apply three inputs, we have to use two different XOR gates. Similarly, here we will need three AND gates, and also OR gate can take two inputs at a time. So we will need two OR gates. So basically, if we go with this configuration, then our connections will be too much hectic and they are very difficult to understand. So in order to get rid of this problem, we can simplify this diagram. So basically we are using this circuit. In this circuit, you can find that we are using two XOR gate, then two AND gates and single OR gate. So in using this diagram also, we will get the same output as above diagram, but the complexity will be very much less. So here you can find friends, we will need three different inputs, A, B and input carry. And similarly, we will generate two outputs, sum and output carry. Okay, so this is basically the truth table. In the truth table, you can find A, B and C inputs and two outputs, sum and carry. Okay, so we have to verify this table with the help of simulation. Okay, so we will start the simulation with TinkerCAD. Let's go to TinkerCAD. So friends, log into tinkercad.com. You will find this dashboard and then click on create and take circuit. So a blank circuit will open. Now give the name of your choice and then drag atoms in the open area. So friends, here you can see I have already dragged some required items. So basically we will need three different ICs, XOR gate, then AND gate, and finally OR gate. And here we will need three different inputs. Taken three different slide switches and we have noted down their names A, B and C. Okay. Similarly, in order to check the output, we will need two different LEDs. So red LED will indicate some output and green LED will indicate output carry. In order to protect LED from overcurrent, we will need two different resistors of 330 ohms each. And in order to power the circuit, we will need power supply. Okay, so if you compare this experiment with half adder experiment, you can find that there we have used only two ICs. Okay, so I have gone with smaller breadboard, but here in order to accommodate all the components, we will need bigger breadboard. So friends, here I have used bigger breadboard. Okay, so only difference is here we can accommodate large number of components. And when you are using physical breadboard, then you have to remember that here in between you can find this vertical line. So it means that this left section and this right sections are different from each other. So you have to connect them in order to do the connections. Okay. So we will start with ground and VCC. So I will connect VCC over here and ground on the top line because our top line indicates minus sign means it should be ground line. Okay, we will change the color of wires. Red line will indicate VCC and black line will indicate ground. Okay, now we are taking these lines on the bottom side as well. Here you can see I have also connected the VCC line on the bottom VCC line and ground line on the bottom ground line. So now ground and VCC are available on top side as well as bottom side. On the physical breadboard, you can see there is vertical line between. This indicates that left section and right sections are different from each other. So many times we have to do the connections in between these two lines like this. So here you can see that now I have connected both sections of VCC as well as ground in bottom as well as top side. Okay. Now let us start with connections. So here you can find that to the slide switch we are having three terminals. So out of this, terminal 1 must be connected to ground and terminal 2 must be connected to VCC, whereas the middle terminal, which is also known as common terminal, it is acting as input. Okay. So friends, here you can see that I have connected ground VCC for each of three slide switches. Okay. Now we are providing ground and VCC to each of these three ICs. So in each three ICs, you can see that ground pin number 7 is acting as ground, whereas pin number 14 is acting as VCC. So likewise, we are connecting ground and VCC to each IC like this. So now ICs are provided with ground as well as VCC. So friends, now we can start the IC connections. On the left hand side, we are having this circuit diagram, and these red color numbers will indicate the corresponding pin numbers. Okay, so first of all, we will start with the XOR gate. So here you can see inputs A and B are applied to pin number 1 and 2 respectively. So I will connect this common terminal of A and B with terminal 1 and terminal 2 of IC. Okay, like this. Now, as per the diagram, pin number 3 is connected with pin number 4 of next XOR gate. So we will connect pin number 3 with pin number 4 like this. And finally, input carry must be connected with pin number 5. So this C, I will connect to pin number 5 like this. And pin number 6 will be your final output sum. So friends, pin number 6 is connected to the first LED, which is nothing but your sum output. And the cathode terminal must be grounded. So it is connected to ground line like this. Now we will start with the connections of AND gate. So in the diagram, you can find input carry is connected to pin number 1 of AND gate. So this is your input carry. So it is connected with pin number 1 of AND gate like this. Then pin number 3 of XOR gate is connected as input to pin number 2 of AND gate. So pin number 3 of XOR gate. So this pin I am connecting as input to pin number 2 of AND gate like this. Okay. Now we will connect for second AND gate. So here you can find pin number 4 is connected with A terminal. Okay. So we will connect A input to pin number 4 and B input to pin number 5 like this. So friends, already we have dragged input A up to this point. Now I will connect this point with pin number 4. So now input A is connected to pin number 4. Similarly, input B, which is available at this point, we will connect this with pin number 5 like this. Now the outputs available at pin number 3 and pin number 6 of AND gate are connected as input to OR gate. So friend, this is your pin number 3. It is connected as input to pin number 1 of OR gate. Similarly, this is your pin number 6, which is connected as input to pin number 2. This connection, pin number 6 is connected to pin number 2 and pin number 3 is connected to pin number 1. And your final output, which is output carry, it will be obtained from pin number 3. So this is your final output. So we will connect this output to LED, and cathode terminal of LED must be grounded. So it will be connected over here. So friends, now our connections are over. Now we can start with the simulation and we can verify the truth table. So friends, now you can see I have opened the truth table on the left hand side. We are having three inputs A, B, C and two outputs, sum and output carry. So your inputs will vary from 0, 0, 0 to 1, 1, 1. And you have to note down the corresponding changes in output. Okay, so here you are having three different slide switches. When the switch is in left hand position, it means your input is logic 0. And when it is in right position, it means you are applying logic 1 input. Okay, so let us start simulation. I will click on this start simulation button. Okay, so now you can see our power supply is active. It means our circuit is activated. Initially, all three inputs are 0. So your both LEDs are off. It means sum is 0, carry is 0. Now, next input is 0, 0 and 1. So 0, 0 and I will click this. So this is 1. So it means your output should be 1, sum should be 1, carry should be 0. So here you can note down sum is 1, carry is 0. So likewise, you can check any conditions or 1, 0, 1. So 1, then B input is 0, C input is 1. So for 1, 0, 1, your output should be 0 and 1. So here you can find red LED is off. It means sum is 0. Green LED is glowing, means carry is 1. Okay, if you take a look at the last condition, all three inputs are 1. So for 1, 1 and 1, your output should be 1 and 1. So you can see red as well as green LED is glowing. It means sum output is 1 as well as carry output is 1. Okay, so for any condition you can check the status of LEDs and you will find that these connections are satisfying this truth table. So in this way we can perform the experiment of full adder using given configuration. Okay, so friends, I hope you have thoroughly understood this experiment. If you do the connections on the physical breadboard like this, definitely you will get the same output. Okay, and there again there is one option for this. If you do not have these slide switches, then you can also use micro switches, which will reduce the number of connections, or it will reduce the complexity of circuit. So friends, you can find micro switches just by searching DIP over here. So here you will get this DIP switch, single pole, single throw. So you can drag this over here. Okay, so it is having 4 different switches. So when it is in lower position, it means your input is logic 0. And when I press on this, it will switch to upper position. It means you are applying logic 1. So at a time you can apply 4 inputs. Okay. So using slide switch, instead of using slide switches, you can also use this micro DIP micro switches also. Okay. So I hope you have thoroughly understood this experiment. If you are having any doubts or difficulties, please let me know in the comment section. So thank you very much. Have a nice day.